Namaste students. In today's lecture, we'll be learning some new formulas related to areas of circle. Do you remember what is sector of a circle? I've told you in chapter 10, when we were doing chapter 10, at that time I've told you what is sector. Area covered by the radii of the circle, two radii, and arc of the circle is called sector of the circle. If we have to calculate area of a sector, so see, this part is being cut at a particular angle. Let this angle be theta. So area of sector will be the area of circle into angle at which the sector is being made upon 360. Means out of 360 degree, what angle is used here to form a sector? Pi r square, that is the area of circle, multiplied by angle at which this sector is being cut upon 360. If this part is a smaller part, if we call it minor sector, then this part will be major sector. So if we have to calculate the area of major sector, for major sector, from the complete circle, if we subtract this area of minor sector, we will be getting the area of major sector. So this will be area of circle minus area of minor sector. That means pi r square minus pi r square theta upon 360. So if we take pi r square common, so we'll be left with LCM 360 minus theta upon 360. You can use this formula also, or simply calculate the area of the circle, calculate area of minor sector, then subtract the two answers, you will get the area of major sector. Next, I have told you about segments. In a given circle, if we draw a chord, then the circle is being divided into two parts, smaller part and the bigger part. Smaller part is called minor segment. Segment means part. And the bigger part is called major segment. Now, if you see, in case of minor segment, if some construction is being done, if I just join the two radii, and if this line is not there, then the complete portion will be sector. And from the sector, if we subtract this triangle, then what will be left? We will be left with minor segment. That means area of minor segment can be written as area of sector minus area of trunk. If from the complete sector we subtract this portion, triangle, we will be getting the area of minor segment. Now for major segment, area of major segment can be obtained if from the complete circle we subtract area of minor segment. So this will be area of circle minus area of minor segment. So using these formulas, you'll be able to calculate area of minor sector, major sector, minor segment and major segment. Let us do some examples to understand the formulas. First example I have taken where they have given a circle with radius 4 cm and theta angle for sector is 30 degree. We have to find the area of sector, means minor sector, as well as corresponding major sector. Radius 4 given, theta 30 degree given. Area of sector I have written pi r square theta upon 360. One thing, just keep here that value of pi is given 3.14. If the value of pi is not given, then we will be taking it as 22/7. If given, then we will be using 3.14. So in place of pi, 3.14, radius is 4. So 4 into 4, theta is 30 upon 360. So after cutting, multiplying 314 with 16 and dividing the answer by 300, we will get 4.19 centimeter square approximately. Now we have to calculate area of major sector. Area of major sector is area of circle minus area of minor sector. Area of circle minus minor sector. Area of circle is pi r square is 3.14 into 4 into 4 minus this 4.19. So 3.14 into 16 minus 4.19. Multiplying 3.14 into 16, you will get 50.24 and subtracting 4.19 from this number, we will get 46.05. We can write it as approximately 46.1 centimeter square. Next I am doing question number 5 of exercise 12.2. In this question, in a circle of radius 15 centimeter, sector is drawn at an angle of 60 degree. Here we have to find the area of minor segment and major segment. Segments will be formed when we will draw the chord. So this portion will be minor segment. Minor segment, and area of minor segment I have told you, it will be area of sector minus area of triangle. So first of all, area of sector, pi r square theta upon 360. Pi again they have given 3.14. R is 15 into 15. Theta is 60 degree. 60 upon 360. So we have obtained 1.57 into 15 5 is 75. We remove the decimal. 25 3s are 25 4s are. Multiplying 1 57 with 3 and dividing the answer by 4, we will get 117.75 centimeter square. Now, as I told you that for finding area of minor segment, we have to calculate area of sector, and from that area of sector, we have to subtract area of triangle. Sector we have calculated, we have to calculate triangle. See here, this angle is given 60 degree. These two sides are equal, means opposite angles will also be equal. Sum of all the three angles is 180. If you calculate all the two angles, both angles will come out to be 60 degree. That means this triangle AOB is an equilateral triangle, and we know that area of equilateral triangle is under root 3 upon 4 into side square. So if we fill the value of root 3, that is given 1.73 in the question, and sides are 15 for this triangle, sides are 15. So if we fill the values, multiply 1.73 with 15 into 15, we'll get 389.25, and dividing it by 4, we'll be getting area of triangle as 97.3125 centimeter square. Now for minor segment, we have to subtract from area of sector, we have to subtract triangle. So 117.75 minus 97.3125. We'll be getting 20 point something. So we obtained area of minor segment as 20.4375 centimeter square. Area of minor segment we have calculated. Now we have to calculate area of major segment. Area of major segment we know is area of circle minus area of minor segment. So first of all, we have to calculate area of circle. Calculate area of circle, that is pi r square. Pi is 3.14, radius is 15 into 15. So after multiplying all these three numbers, we will be getting 706.50 centimeter square. And area of major segment is area of circle minus area of minor segment. Circle we have obtained 706.50. Minor segment we have obtained 20.4375. And after subtraction we will be getting 686.0625. So we have obtained area of minor segment as well as area of major segment.